The function f is defined as shown, where k is a positive constant. And it is a positive constant. That might be important. Show that f dash x is 12x squared minus 8x plus 3k times g of x, where g of x is a function to be found. So if we look at our function up here, it's a quotient where u is e to the 3x, v is 4x squared plus k. So du dx, don't forget to use the chain rule, is going to be 3e to the 3x. And dv dx, that k is a constant, so it's going to disappear, is just 8x. So we need to use the quotient formula here. So f dashed x is going to be v times du dx. So that's these two multiplied together. That is going to give me 3e to the 3x, 4x squared plus k. Now with the quotient formula we have a minus, then we have u dv dx, so that's going to be 8x e to the 3x divided by v squared, which is 4x squared plus k, all squared. So f dashed x is going to be, let's take out the e to the 3x. What do we have if we do that? That is going to give me 3 times this bracket, so that is going to be 12x squared plus 3k. And then taking out a 3 to the x is going to give me a minus 8x there, all over 4x squared plus k squared. And that is going to give me 12x squared minus 8x plus 3k, which is nice because it's that bit. And that is going to be multiplying e to the 3x over 4x squared plus k, all squared. So that bit at the end is our g of x. And we can state that. We can say g of x is e to the 3x over 4x squared plus k, all squared. We're now given that the curve with the equation y equals f of x has at least one stationary point. Find the range of possible values of k. Well, suppose we should state that g of x has no stationary points. To have stationary points, it would need to be equal to 0, and it can't be because the top can't be equal to 0. So any zeros must come from this. So we have 12x squared minus 8x plus 3k, and that needs to be equal to 0, and we want it to have at least 1, which means that we need the discriminant b squared minus 4ac, which in this case is going to be negative 8 squared, take away 4 times 12 times 3k. We need that to be greater than or equal to 0. So that gives us 64, take away 144k, is greater than or equal to 0. So 144k is going to be less than or equal to 64, just rearranging. And that is going to give us that k is less than or equal to 4/9. Remember though that we were told that k was a positive constant, so a complete inequality here needs to be that k is greater than 0 and less than or equal to 4/9.